My lab partner is Brent Baird of Instruments Direct. Brent, how are you today?
I'm doing great. How you doing, Trace?
Doing very well. Thank you for coming on the show. Our second attempt, we had some technical difficulties on my end last time. I guess that's the price you pay when you upgrade equipment.
That's the way it goes. Always something interesting.
Absolutely it is. But thank you very much for joining us today. And we're going to learn all things flow meter.
There you go. How about that?
So I'm curious, you are the flow meter guy, so I know we're talking to the right person, but can you tell us a little bit about your company and what you guys do?
Well, Instruments Direct is a distributor of flow meters, a wide variety of technologies, and it's got an extended history. In fact, the Baird family has an extended history in ultrasonic technology. And over the years, my father, Dr. James Baird, developed the technology for many of the ultrasonic level or sensors that are in the market today. For example, ultrasonic tank level, ultrasonic fish finders, even the beep, beep, beep backup on your car, ultrasonic sensor. He's developed many of these things. And so he was always on the lookout for new ultrasonic technology. So back in the 70s, my father traveled to England to investigate the rumor of a new type of ultrasonic flow meter. And he tracked down the source, who ended up being an old drunken sailor, and for the price of a pint of beer, he told my father this story. Is it appropriate to tell you the story? It's a quick story.
Absolutely.
Well, as you see, once upon a time, there was a sailor who lived in a small sailboat, and he loved to sail up and down the English coast. One day he pondered, wouldn't it be nice to know how fast his sailboat was going? Well, back when he was in the Royal Navy, he learned a thing or two about Doppler radar technology. And after a few attempts, he put together a transducer with some electronics that he towed behind his boat to monitor its speed. Well, he was so excited that he wanted to share his success with his friend, the butcher. Well, the butcher said, maybe we can make some money on your invention. So he partnered with the sailor and he let him use his back room in the butcher shop. Word spread, and before long, the sailor actually got a few orders, and he realized he needed a bigger location to manufacture his flow meter. He needs some money and a location. Well, the butcher convinced the preacher to join the team in exchange for using the church's basement. And then the preacher convinced one of his parishioners, a young wealthy widow, for the much-needed funding. Well, it wasn't long after that trouble began. It appears the preacher was dipping into the poor box to cover his expenses for the weekend trips to the hunting lodge with a young, wealthy widow. When the parishioners found that out, they could no longer play bingo in the church basement, so they put a stop to this, and they had the police evict the sailor and the butcher, and they soon booted out the priest for taking holy money withdrawals. And as for the widow, she headed off to Monte Carlo to find a new husband. My father was so inspired by this new ultrasonic technology, he headed back to Chicago to make his own ultrasonic flow meter. So it all started in my father's basement in 1977, and I was in college working nights as a disc jockey. Brother Brent in the morning at WRW 91.9 FM. My father was the inventor and not a people person, had no clue how to sales or marketing. Since I knew how to talk, I was the elected mouthpiece for a new company called Dynasonics. So over the next 20 years, we developed many ultrasonic technologies. And in 1996, we sold Dynasonics to what is called today Badger Meter. Then I founded Instruments Direct, which specializes in all types of flow meters. So for the past 27 years, I've been producing videos and traveling the country as an educator and a speaker. And things have really changed with the advent of the internet. We no longer have to knock on the door to sell anything. Everything's online. So somehow I get wrangled by my younger employees to get involved in social media. Well, before you know it, I'm an internet celebrity as the flow meter guy. And it actually is getting kind of weird because the last conference I went to, one of the people in the audience said, "Can I get a selfie of you?" And I said, "Sure, come on, get a selfie." And before I know it, I looked up, there was a line of good old boy engineers with baggy blue jeans waiting to get a picture with me. Kind of awkward, but at my age, I'll take any groupie that I can. So hence the flow meter guys really generated from all this online traffic. And then I use that as an educational tool to make my presentations. So that's how the whole thing, and that's how the title got started.
I love that. And your videos aren't just, hey, here's a meter, let me show you how it works. I mean, you get into character, you have costume. It is
Yeah.
amazing all the stuff that you do.
Yeah, I have a problem. And the funny thing is it's many people, it didn't start out that way. As you can see, I enjoy talking to you and I enjoy an audience now, but as a child, I was an extremely overprotected child. I was very shy and very introverted, and this is due in part to my mother protecting her 4 children like a mama bear from evil and pain and the boogeyman. And I got praised for whatever I did, and I could go pick up a rock in the backyard and dust it off and bring it to mom, and she would give me a hug and say, "Look what he made." She would take it and she would put it on top of the refrigerator for all to see. And with all this praising, I developed a problem. The side effect was the excessive attention was that when I walked into a room, I expected everyone to acknowledge my greatness. Problem is, I was more like Forrest Gump. I had absolutely no social skills. When I went out into the world, I got destroyed. And so there's an evolution to get from that point there where I was afraid of my own shadow, afraid to talk to you, to finally getting to the point now where I really entertain myself when we make a presentation. And if you talk to somebody for 60 minutes, 90 minutes, or 2 hours with technical stuff, even I get bored. And so every 15 minutes or so, we'll do a humorous video clip, or I'll play a character live to kind of break up the edge. And if you want to know something's hard, trying to make an engineer laugh is very difficult. So it takes a long time. And if I get re-invited to the same conference year after year, now you have to top yourself. The first year, they're cold, they crack a smile. The second year, they'll laugh, and so on. In fact, the funniest story that I had is I talked to a group of 300 engineers the night before we met with all the conference manager people, and I did a couple of my monologue jokes, and they said, "Oh, this is really funny." So I stand up the next day in front of these 300 engineers and do my fantastic monologue, and it's cricket, cricket, cricket. So then I go into my regular routine. And at the end of the conference, one of the guys comes up, he says, "Brent, that was the funniest opening I've ever heard." And I said, "Well, why didn't you laugh?" He said, "I didn't know that we could." So when you work with
the rules.
when you work with engineers, it's a different life. And so you have to be like them. You have to understand them. You have to talk about their same problems. And they're bored too. So if there's something humorous that you can do, Monty Python-ish kind of thing, if you say spam, 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 everybody replies spam, 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 spam. So this is the world we're kind of in today. So if you thought that engineers had no social media, they're slowly stumbling into this marketplace. And it's become a viable marketing tool for us and a great relief for me to teach technology. And at the same time, not boring the pants off of you for sitting there in a chair. These guys are normally running around the field doing work in the field. They're not really classroom kind of people. And so it kind of breaks the ice to do something like that. So I enjoy it, and they're learning something. And it's turned to be a relatively good source of revenue. As a company, we spend money for pay-per-clicks with Google and things like that. But now we spend more time in video production, and people want to see how to do this. And of course, the guy might do something silly while he's doing it, but they learn something at the same time. And so we've got a following from that. So if I didn't have young people at my building, I'd still be using the fax machine. So as you've all say, you gotta move with the times, or you're out of business.
Just recently, I was part of a group, and we had to do a TED Talk. And we read a book about TED Talks, and then we had to present a TED Talk. And it was all about how do we get the message that is in our head to the other people's head, get them to follow along and entertain them a little bit along the way, but actually give them something that they could use by the time that we were done. That was the premise of what the assignment was. It sounds like you're doing all of these things. I'm curious, what is your process to make sure that you get the end product that you're looking for?
I have an audience here that's a tier group. And as an old guy, I sometimes don't know where the line is to step over. So the first thing when you involve with social media, you hear all the people getting kicked out of social media because they said something wrong. They didn't mean it, but they said something wrong. As another word, as an older guy, every month I'm told another word I'm not allowed to say, which is fine with me. I just don't want, my quest is, if I'm going to make fun, I'm making fun of myself. I use self-deprivation as to make fun of myself. I never want to hurt anybody. So step one, we have to present information that is not offensive to anybody. And the world's changing, so it's a key point with anybody in social media. So we have younger people and older people that go through the queue of the technology we're doing. And step three, when we try to solve a problem, we try to make little pieces of the problem as opposed to a big piece of the problem. People get bored. Everybody watches a video now for a minute or two, and that's the end of it. So we try to make the training material anywhere from a minute to less than 10 minutes because people get bored. And then we have a list of the objective. Here's the problem. This is how we solve the problem. And then are there any questions from that problem? So that's pretty much the format that we use when we do a training or video or presentation.
If somebody wanted to see some of these videos, where can they go?
The videos will be on YouTube. So it's just youtube.com/instruments direct. You'll find them there. You can find them under Brent Baird, under LinkedIn. And most of them are posted. You'll say, what's wrong with this guy, if they're out of context? And sometimes there's more humor than there is technology. And other times there's more technology than there is humor. And as the greatest thing I can tell you is thank goodness for the 16-year-olds on YouTube, because the editing software is so easy now that it could never do this a couple of years ago.
Well, I'm sure you're going to get some more hits on those sites. And Scaling Up Nation, it is worth the trip. I went there just for a second, and I was just so impressed with what I saw and the amount of work that, of course, you put into that. It is definitely worth the trip there. And we'll have all that information on our show notes page so people can find that very easily. To shift gears slightly, let's talk about flow meters. How would you describe to a layperson what a flow meter is?
A flow meter is a device that's going to take an inventory of a process. So, and our main audience is about water treatment, so we're monitoring water. So why do we need a flow meter for water treatment, for example? Well, to treat the water, we need to know how much water we have to begin with to add an additive to correct a problem. So it's to pace the water flow. So a simple version of the water meters outside the back of your house is a device that's above ground or below ground that the city says, okay, you use this amount of water, here's your bill. They have to take an inventory of the amount of water that you're utilizing in your home, your office, and your building. So that's a short story, what a water meter is or a flow meter is.
And they're all various types of designs. How do we get into that?
Well, they're all different kinds of designs. And I think the first question we ask, again, because your audience primarily is in the water, is what kind of water do you have? And I think that's rather a strange question. So the first thing we ask is it a potable water or a non-potable water? Potable water is a liquid that sometimes it's for human consumption. And it meets certain requirements. NSF 61 is a typical requirement. So it's a drinking water quality that humans are going to use. A non-potable water is a water that it's for your industrial process and might be in your cooling tower and other processes within a facility that you're not necessarily going to drink. And why is that an important question? The flow meter that you put in the line or on the line, can that contaminate the water? So the flow meter has to be meeting clean water statuses if it's a drinking water application. So the water that you have on the outside of your house, it's usually a brass flow meter that meets NSF 61 and AWWA drinking water requirements, that it doesn't have certain lead content in the material. And other applications in the food industry, they'll actually need something called sanitary. So if you're in a food facility there, they won't have NPT threads. They'll have special tri-clamp fittings on the end of it, something that they can clean and take on and off. So we ask, what kind of water do you have? So for your audience, the water that comes into the building from the city is usually a potable water application. And then when we're inside the plant, in that case there, a lot of them are non-potable water. And then if you were to break down the kinds of flow meters, it all comes down to, of course, always down to economics. Now, what are you going to pay for? And in your world there, the older technology, of course, we just talked about a traditional city water meter, which have nutating disc or multi-jet. The next step would be older technology, be differential pressure. It might be an orifice plate or a pitot tube, and they're just monitoring the temperature on the left and the right side and looking at temperature or pressure differential to calculate a flow. It's not very accurate, but it's the old method and it's relatively inexpensive, but it's in the line. And then moving up from there, you'd go to a turbine flow meter or a paddle wheel flow meter, which is a device that's like a pinwheel that's in the pipe that the flow turns this wheel, creates a pulse, and we pick up the number of pulses. After that, you would go into magnetic flow meters, and a magnetic flow meter is a device that works on conductive liquids, which you'll have most of the time, that creates, it's like a pipe with a bunch of copper wire wrapped around the outside of it, creates a magnetic curtain. And when the processed liquid that's conductive goes through that curtain, they call it Faraday's law, conducts an amount of current. So the electrodes on the side are kind of like a voltmeter. The more of this conductive liquid that goes through, it measures that, and they're relatively accurate. But it's a flange type device that's in the line. And then the next thing that we get involved a lot is ultrasonic, which is a clamp-on device that measures the flow from the outside of the pipe, kind of Star Trek-ish. You actually take a sensor and you hold on the outside of the pipe and it measures the flow inside the liquid. And they use these in medical industries right now to measure the flow of the blood going through your vein. So it has a wide variety of technologies where you can use this. We're not so much in the medical industry. We're more in the industrial and the process control, wastewater, nuclear, chemical feed, water treatment, irrigation. That's the world that we're mostly in. But there are special equipments that can measure a vein that's a 1/4 inch in size there. So it's a wide variety. So it comes back to price and accuracy, what you're going to use. So in your world, in most cases there, you're going to use a magnetic flow meter or an ultrasonic flow meter, in some cases a paddle wheel flow meter, if it's a low budget item, to tell you that I've got 100 gallons of water coming through here, and I've got to add this amount of ounces of this processed chemical to treat this water.
Are there particular installation concerns that we need to be concerned with each one of those styles?
They have certain limitations, and I do a whole presentation on flow hydraulics. So generically speaking, most flow meters require a certain amount of straight run of pipe, say between elbows. The rule of thumb is if it's a pumped flow, most flows size a pipe around 7 feet per second. So most flow meters require 10 pipe diameters after an elbow and 5 pipe diameters before the next elbow. That's generically speaking. There's some exceptions to that. Some of the new magnetic flow meters require less or little straight run of pipe, but for the most part, that's the industry standard for most type of flow meters. So that's a limitation. And then, of course, then it's the pipe size. If you have something that's in the line, you've got a 1-inch line, you've got to have a 1-inch meter. If you have a 12-inch line, you have a 12-inch meter. So the bigger the pipe size is, the cost would go up because there's more material. The advantage of the ultrasonic flow meter, it's not pipe size limited. The transducers are adjustable, so you could use the same sensor for a 2-inch pipe and a 24-inch pipe. So the price is not going to change.
When we're measuring liquids, we're talking about water, but of course we can measure anything that's flowing through that. How do the meters compensate for the different viscosities, the different densities?
Now, some meters have an issue with that, and some do not. So, for example, the magnetic flow meter has a curtain right across the pipe. It really has little effect on viscosity. And then the viscosities that you're going to use from, say, some of the chemical additives, they're relatively thin. If you had a really thick process like caulk going through a pipe, for example, really thick, gooey stuff there, you'd use yet another specialty turbometer. It's called an oval gear. And that's what it is, a couple of gears turning around that can tolerate those extreme viscosities there. So some of the devices with moving parts will be affected by varying viscosities, and other devices will have no effect. That'll be part of your checklist on what you're going to do.
And you mentioned earlier, a lot of times these meters will feed into some sort of feed equipment so we can dose our products. Not all meters have that capability. So what do we need to look for if we're looking for some sort of pulsing meter?
Well, most flow meters that will have, well, not all flow meters. It's a function of, it's an option. So if you just got a traditional water meter, it's not going to have a pulse output. It'll be a reed switch kind of output. Then you'd have to get one that actually has that feature, a pulse output. Then the next step output you would get from that would be a 4 to 20 milliamp signal, would be an analog signal, and they would also have a pulse output. So most of the ultrasonic and the magnetic come with all that standardly. The lesser the price, the meter, it's usually an option whether it has a pulse output or not. And that'll go to some type of a controller. And the controller, then you're going to say, after 100 gallons, I'm going to trip a relay. and the relay is going to dose something into the side of the pipe. In fact, some flow meters have that ability. You could program the flow meter to say, I would like a relay contact after every 100 gallons. So that's another option with some of the flow meters.
Most of our audience is industrial water treatment, and most of those individuals are treating things like cooling towers and boilers. If we talk about cooling towers, many municipalities are allowing for a diverted water credit. So they're not charging the consumer for the amount of water that's being evaporated because it's not going back into the sewer. What do we need to know about ensuring that we get the proper meter for credits like that?
That's become a popular application. The blowdown you get from a cooling tower, many, as you indicated, municipalities are interested in that. And it's a very difficult application. So the blowdown is basically, the spout that comes from a well when it comes off there. Well, it goes blurp in the pipe. And that's a bad application because, one, the pipe's not full. Then it's really full, coming out like a fire hose, and it's not full. So the bad news is a lot of times in written specifications, they're specifying the traditional water meter, the brass water meter, which has got a spinny around something. And when that hits that, it overspins or underspins and does a very poor job. For applications like that, the first thing you need to do is put a U in the pipe so the pipe will be full all the time. So you need to put a trap in the pipe, basically, and that will make the pipe full. Once you have a full pipe, then you can use an ultrasonic, a magnetic flow meter, or a turbine flow meter, because that takes the concussion of the water out of the whole recipe there, and everybody wants to monitor it. So the municipality is specifying city water meters in that application, which do a horrendous job because it's not designed to work in that application. It's not a full pipe, and then it's overflow on an application like that. So I do a whole presentation just on the blowdown, and just as an interesting story, here in Atlanta, the top of the CNN building a few years back, they had this partially filled pipe application, and we proposed to put a trap in the line, and they opted to put a weir box in there. So we have giant 3-foot weir boxes because it's partially filled on the roof of the CNN building. So we got a high-tech organization there with low-tech ancient stuff on the roof of the building, but that's how they monitor it. And the city mandated that they had to monitor the effluent from the towers with something like that. So a difficult application at best. If you have the choice, put a trap in the line, then you have a whole opportunity of flow meters that you can put in the application.
That is great advice. And you said you had a video on that. I'll make sure I get that information for you and link it to the show notes page for all of our audience. What are some of the biggest installation mistakes that you've seen with some of your meters?
Well, every day is interesting. The biggest mistake, of course, I said, is probably lack of straight run of pipe, where they'll basically just have 2 flanges and a couple inches in between it, and they'll put something like that in there. A lot of the installations are pump testing. So if they go to a new wastewater treatment plant, they're building a substation or something like that, and they'll have a 36 or 48-inch pipe. They need to test the pump performance to sign off on a project there. They'll have a problem because they're going from a wet well through the pipe back to a wet well. So the water that's going through the pipe is highly turbulent. It's like going through a washing machine, very turbulent and no straight run of pipe. And they want the ability to validate the pump. That's always been an interesting application because the test of the pump doesn't actually perform the same application after they certify the pump. So if you certified the pump, there'd be head pressure on the pump, the line would be full, and we wouldn't have a problem with flow metering. So we have an extremely, extremely turbulent situation. So sometimes we have to try different kinds of meters or clamp on ultrasonic flow meters. The transit time ultrasonic flow meters require a straight run of pipe on clean liquid. And if they don't have the straight run of pipe, the turbulence will knock that out. Then we may have to try an ultrasonic Doppler flow meter, which works like radar. It bounces off suspended particles or turbulence, but that's not as accurate. So it's a very difficult game. So when they specify testing, they don't really take into mind what the testing requirements are from the flow meter people. So that's an ongoing, interesting problem that we have all the time. Give us some straight run of pipe, give us a little head pressure, give us a full pipe, and then you have a whole lot of choices to use the right flow meter technology.
The equipment we use is getting smarter and smarter, and soon Skynet will take over the world. But until that happens, I'm sure there's some great innovations that are happening with flow meters. What new features should we be looking for, and what can we expect in the future?
Well, from the flow meter side, of course, the best way to go is get out of the pipe and go on the outside of the pipe. So that's the magic side there. And so the technology is evolving with the ultrasonic technology that. And years ago, you had to be very specific about the type of processed liquid and how nice and clean the pipe was. And it was a lot of parameters to make the device work right. And now the technology is moving forward to that they have autopilot functions. The electronics, the portable electronics are about the size of a voltmeter. And they have diagnostic screens that you don't need to see. So the technology is such that it's autopilot. So you turn it on, it does its business, it is done. If you were to go actually look at the diagnostic screens behind the things, you could see the thing going nuts trying to find the best parameters to work with. So I would say the autopilot functions of the devices are, because of the microprocessor and all these different methodologies with the software, getting better and better every year. There's less you need to do. So we'll take a $6,000 portable ultrasonic flow meter and rent it to Pete the plumber, which has never seen one before, give him a one-page operation manual, step 1 through 6, and he's successful. 5 years ago, he had to go to class for 2 weeks to learn how to operate the device. So the user-friendly, I think, is the key in all flow meter technology. The strive is to make it so you don't have to be a trained technician to operate the device, and you should get the same results as a professional person that operates the device.
So all this great equipment, you're telling us all these neat things that it can do. How do we know it's right?
How do we know it's right? So I always say the man with the 2 wristwatches, well, the one on the right wrist is right, damn it. And attitude does play a role actually from time to time. We first walked out with an ultrasonic flow meter years ago and held it to the pipe. The customer says, how do I know it's right? This is magic. You're putting a device on the outside of the pipe. Well, to validate a flow meter, what will commonly happen is they'll have a flow meter installed in the field. Say it's a magnetic flow meter, and they'll say, I'd like you to validate this. So they would rent or buy or own a portable ultrasonic flow meter and go downstream and clamp it on the pipe. And if the 2 flow meters say the same value, you're happy camper. Everybody's happy. If they don't say the same value, then we have come out with the testing device, which has a current calibration certificate just done by our lab or any other laboratory that says this flow meter is calibrated against this traceable 0.25% meter, and this certificate says it's accurate. So we use the piece of paper to validate that's better than the meter that's in there. A lot of devices that are installed wear out over time. So the biggest sin you could ever do is you say, you know what, I want you to replace my city water meter. I can guarantee you the next billing cycle will be higher. The older the city water meters go, the slower they get. And that's why the city changes them out from time to time. So when we go into the field there, you have to have credibility. And I did say attitude actually plays a role. When we go in the field to test another meter, we'll say, this meter's right, damn it. And here's our calibration certificate. And sometimes it takes the authority nature to actually present it. And again, if they don't like it, they can pull that flow meter and send it to a laboratory, and they can do their own flow testing, which in many cases is not a practical thing to do. So that's why we come to the field or rent, or they have their own equipment to go to the field to validate the test equipment. That's a common question. So although many meters don't require annual calibration certificates, some government regulatory say, I'd like to see your annual certificate that the meter's been calibrated. So it's sometimes just a paper trail, and sometimes it actually has some relevance to the situation.
If we're ever doubting the effectiveness of the meter and we need to troubleshoot, what are some key troubleshooting steps that we all need to know about?
Well, as far as troubleshooting steps, the first thing would happen is the meter faults, it stops reading. What's the problem with that? And that's the most common. It's a mechanical device, and obviously there's some mechanical failure. There's something in the line, something got caught up on the device there. If it's an electronic device there, with mag meters or some other meters, the first thing you want to do is check the electrical ground. Some applications, the environment is just so horrendous. When you walk past a transformer, it pulls your belt buckle towards it. They have very bad earth ground. So sometimes you actually have to go in and remove the ground wire, and you'll find that the device works better. The ground's so noisy and the ground's causing a problem. There's filters you can add to a system like that. So those are the things to look at. And some of the older devices actually are that use variable frequency drive pump controllers. The VFD itself does cause some problems with some electronics. It's not supposed to. I've had places where VFD drives were in a wastewater treatment plant and it screwed up everybody's television set for a block around. So they're not supposed to retransmit their frequencies, but every once in a while there's noisy environments that affect all microprocessors. So it doesn't happen every day. So, and then the last thing people ask is what's your signal strength and things like that. So each flow meter has its own list of diagnostics, but they're user friendly enough that you can get somebody on the phone from our organization or any other organization, say, here's my problem, and they'll say it's error code this and this and this, and it equals this. So again, it's moved to the user friendly status. Everything's getting better. Data loggers, for example. In the old days, to get a data logger, you couldn't communicate with the cable or Windows or anything like that. A lot of the new meters don't even use software. They just save the data as a CSV file on an SD card, and you put it in Excel, and you have no software. So it's becoming more and more user-friendly every day.
Well, Brent, we have learned a lot about flow meters today. And if somebody wants to contact you directly, what should they do?
Well, you can call Instruments Direct. It's instrumentsdirect.com as our website. And our phone number is at Instruments Direct for me is 888-722-5543. And if you have any educational opportunities, that's what I do. Is my job is to travel around as a teacher. And so if there's some way that I can help your organization do something like that in any of the industries we talked about, let us know how we can help you out.
Well, awesome. Well, I have a few more questions for you just to get to know you a little bit better. We call these our lightning round questions. So are you ready for those?
Shoot.
All right. So the first question, if you had the ability to go back in time and talk to your former self on your first day as you were getting into flow meters, what advice would you give yourself?
Well, don't live home with mom until you're 20. That's the first thing. Then you'll learn life a little bit better. But I think the key is when I got involved in the business, you have to learn mano a mano. I have to be like your people and the customer. My first service calls, I would walk out to a paper plant in South Georgia, and I had a blue suit on. And they would take me through the paper plant, and they knew I was a rookie. By the time you walked out, it looked like a flock of seagulls flew over top of you. You're covered with everything. And it kind of realized that I was not being like the customer. So you have to dress like the customer, you have to act like the customer, you have to work with the customer. And that took me many years to evolve into being just like the customer, because that's the person they want to buy equipment from, and they understand and they respect your knowledge about the technology. So that, I think, if I could move up that time span a little better, and as I got older, I'd say the next thing, now that I'm an older guy, I learned about 10 years ago, is I can't micromanage everybody. Hire smart people and surround your people with smart people and let them do their job. You want someone to do marketing? Here, go do it. You want somebody to do sales? You go do it. You look at the numbers and what you're done with that, but get out of their face and let them do their job, because that's what they're there for. So you got something else to do.
Great advice. What are the last few books that you've read?
Well, as I said, I'm a nerd. The last few books were The Theory of Sound by Lord Riley, which is the inventor of the transit time technology. It's an archive book. It's written in 1877. The next book I read was The Aqueduct of Rome, which is another character I played, was Sextus Frontinus, the first water commissioner of Greece. And then my favorite book of all is The Salesman of the Century by Ron Popeil. Pocket fisherman, slicer dicer.
The spray-on hair guy.
The spray-on hair guy. He was the first. He was very charismatic. He used to sell at fairs before he got involved in this other stuff. He was the first really snake oil salesman, huckster. And if you read the book on that, it's a very interesting read.
When Hollywood makes a movie about Brent, who do you want playing yourself?
I like Tom Cruise, but I'm much taller than he is.
Wouldn't work. If you have the ability to talk to anybody throughout history, who would it be with and why?
For history. I said I would like to talk to, as I mentioned, the Greek Sextus Frontinus. He was the first Greek water commissioner, and he basically administrated the aquifers. And he was responsible for developing the first billing of the waters to the city of Rome for residential use. They didn't have flow meters there. They just had nozzles. So based upon the pipe nozzle that came to your spa, you were billed on that amount there. So it's surprisingly, they have a lot of this information about the aquifers and how they're built and the engineering, but they don't really have the politics of it. It's not all published information, and I find that bring all that water into a city, and that's how the city basically survived, and that's why they're healthy. Just an amazing story, and there's very little documented about it, and I'd love to learn more about that.
You can find yourself a DeLorean and bring them a flow meter.
That's right. There's probably one on eBay.
Brent, thank you so much for coming on Scaling Up H2O today and teaching us so much about flow meters.
Thank you for having me. I appreciate it, Trace.